Chapter 6 starts by talking about the condensed phases of matter, which are solid and liquid. We know that gaseous elements, which are under room conditions, found only at the top right-hand side of the periodic table. So in the periodic table, you will find the gases where, at room temperature, the hydrogen gas, H2, and then there is nitrogen and oxygen, N2 and O2. These are all diatomic gases. Then in group 7, there is two gases, F2 and Cl2. Then you will find all the noble gases. They are all monoatomic only. So we have helium, we have neon, argon, krypton, xenon, and radon. So if you count it, you will find how many gases are there at room temperature: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 gases. 1, 2, 3, 6 are from the noble gases. Hydrogen is 1, nitrogen and oxygen, F2 and Cl2. This is a potential energy diagram. Don't be afraid from this diagram. It's easy. This is the energy store that's ready to be used. So think that you have a big dam, and under this or behind this dam, there is a lot of water. This water is waiting to flow behind the dam. So it contains a lot of energy stored in it, waiting for the dam to be opened or broken. So it goes to the other side. The potential energy diagram shows how many heat is in each phase. So matter comes in 3 states or phases: the solid, liquid, and gas. The solid holds their shape, liquid flows, and gases spread out to fill the space. So the gas is the phase or the state that has the highest potential energy. The liquids has lower potential energy. The particles of the gas are moving freely everywhere. They have high potential energy stored in, and the liquid gases have less, and the solid particles are not moving at all. They don't have any energy. They have very low potential energy stored inside them. The phase changes is what happens when you change one matter from one state to other. So you change liquid to gas, solid to liquid, gas to liquid, liquid to solid, or even solid to gas directly. We know the names of these phase changes. But before discussing the names, we know that in order to change from one phase to another, you need to change the energy. So sometimes you need to absorb energy, and sometimes you need to release energy. So for example, evaporation, which we might call also vaporization, because you make vapor, this is changing the liquid into gas. To change from something which has low potential energy into something which has higher potential energy, you have to gain more energy, and you can gain this energy by absorbing energy. So your potential energy increases. And if you want to move from solid to liquid, that's what we call melting or fusion. In melting, this one changes from the solid phase into the liquid phase, changing from substance or phase which has low potential energy to a phase which has higher potential energy. So you have to absorb energy again, so that your potential energy will increase. If you are doing condensation, that's changing from the gas into liquid. So changing from the gas into liquid, so this is called condensation. Here, you change from a phase which has high potential energy into a phase which has low potential energy in liquids. So where is this potential energy that's going to decrease going? It's going to be lost. So you lose energy. You lose energy because you will decrease the content of your energy. So you lose this out. Also, the same happens if you are solidifying. So solidification or freezing, you are changing from liquid to solid, from something which have low potential energy to even lower, very low potential energy. So where is this potential energy going? It's going to be lost. We have sublimation. Sublimation is when you change from the solid to gas directly. So without going through the liquid phase, bypassing. When you bypass the liquid phase, you change from the solid to the gas. Here again, your potential energy will increase. So you need to absorb energy so that you increase. And the opposite of sublimation is sometimes known as deposition, in which you change from gas to solid without moving to when you decrease the temperature of certain substances, you change them from gas to solid directly, without going through the liquid phase. Here, the energy will also decrease. So how do you decrease this energy? You will decrease energy by losing it. You will decrease energy by losing it. You will release energy. So this means anything which is going from down to up, the arrow is up. This is an endothermic change because you needed to increase your energy. So you needed to absorb energy. So it's called endothermic. The potential energy increased due to absorbing energy. You have low into high, so you absorbed energy. While anything which is going down, like condensation, freezing, deposition, what happened here? The potential energy decreased. Why? Because you have lost energy. The gas has very high potential energy. You made condensation, you change it into liquid, so you have now low potential energy. Why? Because you have lost energy. This is called exothermic reaction. So anything which is arrow up, moving from solid to liquid or liquid to gas or solid to gas, this is endothermic. And anything moving down, from gas to liquid, from liquid to solid, or from gas to solid, this is energy lost. This is exothermic reaction. So this is an exothermic reaction. Now, the exothermic reactions we can summarize as condensation, freezing or solidification, and deposition, while the endothermic reactions are vaporization, evaporation, melting, and sublimation. Exothermic reactions, any reaction that consumes energy, you absorb energy, you get energy, you take in energy, while exothermic reaction is a reaction which the system releases energy to the outside. You lose this energy.